Hello, okay, let's talk about functions. Well, what is a function? A function is simply anything that maps an input to the output. Basically, it links the input to the output. That's as simple as it gets. So here I have a visual example that you might understand better with. So it is, if I tell you to pick any input, right, any number, and I tell you to put it through a machine that would give me an output. So it could be anything. In this case, I put in 1 here and I get a 3 here. So there's a machine in a sense that's taking 1 and it's making it into 3. It's taking 2 and it's making it into 4. It's taking 3 and it's making it into 5. So what we need is we need a machine which is going to be a function. It's just a metaphorical function. So we want it to take in 1 here and give out 3 here. We want to take in 2 here and give out 4 here. Take in 3 here, give out 5 here. So this box that we have here, this box is basically what our function is. So this could be our function. And a function is anything that maps x values to y values. Now you may ask why x and y. That's just what is usually used. When we have our coordinate axes, we just use x here, we use y here. That's just how the standard variables are. You could use m, n, any variable actually. It depends on you, but usually we use x and y. Now let's try to get the notation right, because we're not going to be writing functions every time we want to define a function. So let's say function notation. What is a function notation? So we're not going to be writing this every time we want to define a function. Whenever we're defining a function, we basically mean what we're trying to say is that we're trying to make a machine that will take an input and give us an output. Okay, so what we're trying to say here is that these arrows can represent the function. Okay, so the notation for a function is f of x. It's called f of x. It kind of looks like f is multiplying x, but that's not really what's happening. This function, the f of x, is basically telling us that the x here is going to be all of our inputs, and then everything, so this entire thing is going to be our output. Okay, so that's not the only notation. We also have something like f of something like this. Yes, so here we can have our function. This is basically telling us that whatever we have to the right hand side is basically what our metaphorical machine is. So now we're going to try and use a notation, and we're going to move forward from the idea that a function is just a machine, because it is a lot more than that, and you're going to see how, because I don't really need to tell you, you're just going to find out. So let's start here. So let's say f of x is equals to 2x plus 1. This is a very simple linear equation here, or linear expression I should say. This is a simple linear expression, and this is saying this is a function in terms of x. So the x says it's, the function is in terms of x. If I were to have something like y here, then I would have to change the x here to y. That would tell me that the function is in terms of y. Okay, but we usually use x, so I'm going to stick to that. So that's what it basically says. Now we could also write this as this. Oops. As this. So these two mean exactly the same things. They're both the same thing. You don't need to worry about it. You can use either of the notation. I prefer to use this one because it's less to write and it's faster. So I'm going to be using that. Okay. So next I have to tell you, we can also have we can define a function with f. So we can use f of x. We can use g of x. We can use h of x. We can use any alphabet we want. Okay, There are some alphabets we tend to avoid, such as E, I, because this is a constant and this is an imaginary number, so we tend to avoid them, but you can use them in the given context. So what if I want to find a value using f of x? So let's say f of x is still equal to 2x plus 1, and let's say that x, let's give it a value, x equals to 1. So how do we find a value here? So to find a value, all you will have to do is say f of 1 is equals to 2 times 1 plus 1. Now notice that every so as you can see, we have an x here, we have an x here. In the second expression, the second step, we've changed the x to 1 here and here, everywhere we have x. So why did we do that? Because we know that now we said that x is equals to 1. So for us to get rid of the x, we just say, well, x is equals to 1, so why don't we just put x all the way over here, everywhere in place of x. So when we do that, we can see that, well, this is simplifiable, and when we do simplify it, we get that is 3. So f of 1, I should probably use equals to 3. Okay, so well, that makes sense, because when we put a number inside here, or well, inside here, we should get a number outside here. Okay, so however, we can't say f of x is equals to let's say a value a. Let's say f of x is equals to 2 plus x, and then and I could say g of x is also equals to x squared, maybe. When we do that, all we have to do is f of 1 is equals to 2 plus 1, and f of 1 will then eventually equals to 3. Here, g of 2, we know that g of 2 will be equal to well, x here, so 2 squared, put brackets around that, and g of 2 is equals to 4. There it is. So these are our answers. It is a very simple concept. F of x is equals to let's say 1 over x. If you are wondering what this looks like, I can show you. This looks like this, just the positive part. So this could be y, this could be x, and this is f of x. But this is not important, but if you do want to, this is what you can use to maybe understand it a bit better. Okay, so there is one very important rule in maths, which is you cannot divide by 0. And if you see in this graph, x is almost never 0. It's just not 0, because if it is 0, then we would have 1 over 0, and we can't have that. So what we would do is we would say that here x cannot, that is then x cannot equal to 0. This is what the equal sign with a slash between it means, that x cannot equal to 0. When we say that, but we can also say that x, or x is a member of all real numbers. This is called a domain. Okay, and a domain is very important in cases such as this, in cases such as this. Let's say you have g of x is equals to this. A domain is very important here, because we can't have the function breaking. If the function breaks, then we have a problem. So here, x must always be greater than 0, greater than or equal to 0. So the reason for that is that if we were to have a value less than 0, so we could say square root of 0 is 0, so we know that there is a real value. What about square root of minus 1? What's that? Well, you can't find that with normal real numbers. So its actual definition is I. But don't worry about that, that's not part of the syllabus, we're not going to go over that. Oops. What this tells us is that x must always be greater than 0, so that the function always remains unbroken, if you may. Okay, so this is what a domain is. It helps us. This is also a domain. Hold up. Domain. A domain helps us to basically avoid the function being broken, which is what I could tell you. So it tells us the x values that are possible. So here in this case, we can never put x equals to 0, because if it's 0, that will be indefinite. You can check that on your calculator as well. The calculator is allowed in this exam, except for a few questions, but you can check by yourself. But every other value will give you an actual value. So it's valid. As long as it doesn't break the function, it is valid. Okay, f of x is equals to 1 over x plus 1. Well, how in the world do you find the domain of this function? Well, if you think in a way, you will find that well, the function breaks if if you have something like 1 over 0, right? And we can never have this. So let me just put a red. Never have this. So to avoid that, what we can do is that let's take the denominator. And let me use black here. Let's say x plus 1 equals to 0. Well, what we're trying to do is that we're trying to equate this to 0 so that we know what value of x not to use, if that makes sense. You're gonna see. So x equals to minus 1, because when we have minus 1 plus 1, that will give us 0, so it's fine. Okay, so x equals to minus 1. If we have x equals to minus 1, then we will get 0 over here. But what we're trying to do is we're not trying to get 0 here. So I hope it makes sense, because now what we're going to say is that, well, f of x equals to 1 over x plus 1, where x cannot equals to minus 1. Because if it were to equal to minus 1, we're going to have 1 over 0, and that is not allowed. Okay, so, but every other number is fine, so we can say x is a member of all real numbers, and that is our domain. and that's basically what it is. That is all it is. It's basically the hardest it gets, hopefully. And I can give you another example. Let's try another example. Let me use g this time. I should vary things. Let's say 2x plus 1, but it's square rooted. Oops. Okay, here we know that in the properties of a square root we can't have negative numbers, so no negatives. This is how you write a short form of negative. Okay, so you can't ever have negative numbers. How would you have a negative number here? Okay, well, let's say that if the number is less than 0, right? So let's use 0 again. 2x plus 1 is equals to 0. Well, x will equals to minus 1 over 2. You can use your calculator for this, or I could take extra steps. 2x is equals to minus 1. X divide 2 on both sides. X is equals to minus 1 over 2. So if x were to equal to minus 2, we would get 0. But the problem is that, let's rewrite this, because we're trying to get something less than 0. So 2x plus 1 should be less than 0, right? So we're saying that if this is less than 0, then the function breaks, and we're trying to find the value, or the biggest or the lowest value where the function will not break. So let's try to find that again. So this will still be minus 1 over 2. The sign just changes, so it's fine. You can go over it again, and this acts exactly as the same way as a equal sign would act if you're trying to solve for anything, but you have to be careful of what this is. Okay, so now we need to, let's check using our calculator. If we were to say that 2, well, this can also be equal to this, because if x was equals to minus 1 over 2, then, well, our answer would be 0, and square root of 0 is still 0, right? But then we're saying that anything less, so x should be less than minus 1 over 2, or x should be equal to or less than minus 1 over 2. That would break the function. Okay, but we know that if we include 1 over 2, we're going to get an actual answer. So we can just we can say that it's less than minus 1 over 2. Okay, now that's settled, we can try this out. We can say, well, anything less than minus 1 over 2, we could say minus 1. So 2 times minus 1 plus 1, square root everything. That should give us minus 2 plus 1, and that is minus 1. Square root of minus 1, and that is not allowed. So you can try more examples. You could say, let's say minus 1 over, let's try minus 2. As long as it is less than minus 1 over 2, it should work, and it should give us minus 4 plus 1 minus 3. And this is also not allowed because we don't have actual values for this. So what we found all the way over here is that when x is less than minus 1 over 2, a function breaks. It's as simple as that. Function breaks and it's a problem. So yeah, that's the issue. So we can't have that issue, stopping us from graphing the function, because later on we're going to have to graph these functions. So we need to know the domain and where the function breaks and where it doesn't break. And below these values, or in this range, the function breaks. So we need to be very careful. Okay, so I think that is the domain of this function. Domain. You could also write x is also a part of all real numbers, because anything greater than this, any x value greater than minus 1 over 2 is allowed. So we can add that in. So yeah, that is it for domain. Okay, let's move on to range. Okay, range is simply the height of the curve. Yeah, so all you have to do is look at, let's say f of x. Actually, it's probably better to graph this first. Okay, so if you have a curve like this, well, you know that at this point, this is the lowest point of the curve. Below this point, the curve does not exist. So we could say that, let's call this value a. So we could say that f of x is always greater than or equal to a. That will be the range of any function that we have. And usually some exams use f. You can also use f of x. It doesn't matter. Okay, now let's use a function. We're not going to use this for now, but we're going to say equals to x plus 1. We can graph it, which is usually just like this. X plus 1, f of x is equals to x plus 1, and this is y, this is x. Okay, so you don't really need to worry about what the function is telling you. Just look at, or just, if you can, just imagine how it would look like on a graph. If you can't, which is fine, you can just use a very large value for x and see if you keep getting a higher and higher value. So if you have a linear equation, there is no minimum or maximum point. Your line is just going to keep on increasing that way as long as x is increasing. So that means f is simply part of all real numbers, just like the domain. And so this would be the range. And the domain for this would simply be, well, there's nothing that breaks the function, so x is part of all real numbers as well. As you can tell, this is what the domain and range would be for this function. That's simple enough. Okay, let's try something else. Let's try maybe okay, let's try 1 over x. Okay, so 1 over x, the domain was, well, x can't be equal to 0, yeah, but x is a part of all real numbers. So that's the domain. The range for this is, I could have advised you to use a calculator. So just do 1 over a very large number, 1 over maybe 10,000, and you would see that, well, this curve is actually approaching 0. So the greater values of x you have, So as x tends to infinity, so the bigger the x gets, g of x simply tends to 0. What that means for us is that, but it never touches 0. It's never exactly 0. It's going to be like 0, 0, 0.0000, like I don't know how many zeros, but then there'll be a 1 at the end, because it's not exactly 0, or it could be any value, it doesn't matter, but it's not going to be exactly 0, okay? So it's going to be slightly greater than 0, but it's not going to equal 0 ever. Okay, so for us to write that down, we would say that, well, g of, well, I guess g of x is always greater than 0. Not equals to, because it never touches 0, but it's always greater than 0. It's going to be very, very quick. So we have 1 to 1, we have 1 to many, and we have many to 1. Okay, so there's not a lot of explaining this, but basically whenever you have an x value that gives a unique y value, so one x value gives a 1 y value, that is a 1-to-1 function. Okay, 1 to many is simply one x value gives you multiple y values. That's how you spell multiple y values. And then finally, many to 1 is simply multiple x values gives you singular y values. So you can see the first one in action here when you have a line like this. You could have x values here, y values here. So if you have any x value here, you're going to get a singular y value. There's not going to be any other x value that's going to give you another y value. That's just it. Okay, so for the second one, it's okay, many to 1 to many, sorry, which is just going to be 1 to many. Okay, something like this. So if you were to find, so we know that this and this point have the same y value, call that y1, but we know that it has different x values. Okay, so these two x values give the same y value, so multiple x values giving the same y value, which is many to 1. Okay, and many to, okay, I mean 1 to many, sorry. The last one is many to 1, which is something like this. When you have one x value, or one, I guess, yeah, one x value giving you two multiple y values. That's y1, y2. So that's what it is. These usually don't have an inverse. Okay, so let me just number them. Okay, so a lot of the times we need to combine functions. So let's see. F of x is equals to, let's say, x squared, and g of x is equals to x plus 1. Okay, well, how do we combine this? We can't just say, well, f of x plus g of x, because that will only give us x squared plus x plus 1. That does work, but what we haven't combined the function. We need to like use the x values here in here, which is to do that, all we have to do is simple. Or basically we can say something like, well, we can say in terms of x here, put g. Yeah, so it was something like this. What does this mean? What is this function saying? Well, what it's saying is that wherever you see the x value of inside f, put the function g in it. So here we have f outside, so we would take, well, the x value, and then we're going to put g in it. So x plus 1 and then squared. This is fg. This is how it works. Okay, we could also have g of f. So we take g and we put in f. We put the f function inside the g function. So you just say x squared plus 1, and that's it. This can help us if you have something, you know, f, g, h, f, f. So we could just combine all of these functions into one and then get a value or get an expression that we can easily use. Okay, so that is why we have to combine functions, and you'll have to combine a lot of these functions. Let me get some examples going on here. Okay, so what is the first one saying? It's saying that, well, take the function g and put it into f. Well, that's no problem. First of all, you have to do is write out g, x squared plus 5, and they'll just put it into f, which is just going to be 2 plus 1. Oh, sorry, minus 1. Because if you remember, this was our x, right? So assume that all of g has turned into x. So when you do that, this is basically something like this. So take everything in g, put it into f. It's as simple as that. And okay, that's it. So now we can simplify 2x squared plus 10 minus 1, then 2x squared minus, well, plus 9. So f of g of x is equals to 2x squared plus 9. Okay, next is b. It says g of x, g f of x, like this, right? So it's saying everywhere you have x, just put f of x. So all we have to do is write out f of x, 2x minus 1, and then we'll put it into g, which is just going to be x squared plus 5. This used to be x, right? And we replace it with f of x. That's pretty much it. Okay, and we can expand this. That should be 4x squared minus 4x plus 1 plus 5. This is correct. 4x squared minus 4x plus 6. Okay. Yep, usually you will have to simplify these. Oh. Okay, last one is f squared. Okay, f x. Okay, this is a bit weird. What is this function saying? It has a square in it. Okay, well, let's try to interpret this question a bit differently. Usually we had, you know, something like g of f of x, f g of f g of x. Okay, but here we have f squared. So, well, we know f anything squared. So like x squared is equals to x times x. So what if this function is also saying f of x? So like take f and put it into f again. So that's what it's saying. Take f and put it into f again. Right? This is what it's trying to say. But this is like the condensed form. Okay. So let's do that. 2x minus 1. So let's write 2x minus 1. Well, 2 f of x minus 1. So let's simplify this. 4x minus 2 minus 1, 4x minus 3. Yep. So f squared of x is equals to 4x minus 3. This is how you do it. Okay, so when you have something like this, which usually comes a lot during the exams, by the way, so I guess this could be an exam question, but it doesn't really matter because we have to solve it. So to do this, you have to think very carefully because you cannot make a mistake in these. From what I'm looking at, we're going to have a very ugly looking fraction. So let's get to it. Because what we're doing is that we're going to take f of x, everything here, and we're going to put it inside g of x. Because that's what the function is saying. Put f of x inside g of x. So well, let's start. 3x plus 5 over x minus 2. That'll be minus 1 all over 2. Okay, so by the way, don't forget that it's also equals to 12. So that means we're actually going to be looking for an x value. Okay, so you should probably have your calculator out by this point. And just to simplify things, I'm going to multiply 2 on both sides. just to get rid of the 2 here. So 3x plus 5 over x minus 2 minus 1 equals to 24. Just want to make sure I did not skip any steps, make any problems. Okay, so what I'm going to do next is I'm going to take the minus 1 to the other side, so that it becomes 3x plus 5 all over x minus 2 equals to 25. Okay, now next thing what we're going to do is we're going to multiply on both sides by x minus 2. The reason for that is that I want to get rid of the fractions, so I'm going to be able to do that this way. So 3x plus 5 equals to 25 x minus 2, and I'm going to simplify this so that I can solve for x then. Distribute 25 times x, 25 times minus 2. This should give me 25x minus 50, then 3x plus 5. Okay, so I want to keep things positive, so I'm going to take this minus 50 all the way over here, and I'm going to take this 3x all the way here. This is going to keep things positive for me, so I will do that. This will make me, this will give me 55 equals to 22x, probably. I hope I've done this properly. So next I'm going to divide on both sides. Okay, so when I divide on both sides, just so I isolate the variable, this will give me 55 over 22 equals to x. Now you can simplify this using your calculator, and this will give you 5 over 2 equals to x. Obviously you don't have to show every single step that I've shown here, but just so you understand, this is how you would find your x value, and I hope this is correct. So if you aren't sure, you can also put it back into, I would suggest you put it back into maybe this equation. Modulus functions are simply, if you have f of x here, you just put these like bracket kind of things around it. What this does is that it makes every single output positive. Going like this, let's say this is f of x. So the graph of f of modulus of, let's say this is f of x, right, and this is f of x modulus, this is f of x. The f of x modulus graph will simply just go y, because well, all the outputs are positive now, so this line will simply flip. And if you notice that there's going to be a line of symmetry here, if you could notice this line of symmetry, so this line just flips all the way to this line. So here now you end up with something like this. This is modulus of f of x. Keep in mind that the x values is not affected. Oops. Only f of x is. Okay. Also, you need to know how to be able to find values using f of x. It's the modulus sign is equals to 5. So to do this, all you have to do is well, simply solve for 2x plus 1 equals to 5, but you also have to solve for minus 2x plus 1 and then brackets, come on, equals to 5. So this is basically everything you have to do. So here we can solve for 2x equals to 4, take the 1 to the other side, x is here equals to 2. And then here we have minus 2x minus 1 equals to 5, minus 2x should then be equal to, take this over there, 6, and then x should be equals to minus 3. Okay, so these are the two values we've gotten that will give us the answer here, 5. You can check this using your calculator. So, and that's pretty much all there is to modulus functions. if you have something like, let's say you have x plus 1 modulus over 2x modulus, this is the same thing as saying x plus 1 over 2x everything modulus. Okay, so don't get that confused, and all you have to do is just, whoops, if let's say this is equals to 5 maybe, all you have to do is say, well, x plus 1 with 2x is equals to 5, and x plus 1 over 2x is also equals to 5. And then I would like to take this minus to the other side by dividing on both sides. Remember, this is minus 1, so you could divide here by minus 1, divide here by minus 1, and this would obviously go away, but this would turn into minus 5. Okay, so this makes it a bit easier for me. So 10x, and then 1 is equals to 9x, because this goes to the other side, and 1 over 9 is equals to x. And then here we have x plus 1 is equals to minus 10x, right? Multiply on both sides, take 2x to the other side, 0, and then 11x is equals to minus 1, and x is now equals to minus 1 over 11. That was just a random example, but this is how you would do it. Okay, so the inverse functions are extremely simple. All you have to do is, remember how we had 1, 3, 2, 4, 3, 5. So this function, like going to the right, let's call this function, well, f of x, right? What about going backwards? What if you want to take 3 and we want to go back? Right, what if you have the output and we want to get the input? Well, all we would have to do is, well, inverse the function. Like, put it backwards in a way, so that we can do that. This is the notation, by the way. So this is the notation of inverse functions. Okay, so, well, there's only one way to show you, which is giving examples. The first thing we can do is, let's say f of x is equals to 2x plus 1, like we've been using before, and we want to find f inverse of x. How on earth do we do that? Well, there's a simple way. All you have to do, hold on. So the first thing you would do is say y is equals to 2x plus 1. Next you would just switch the places of y and x. Put y here, put x here. So x is equals to 2y plus 1. And next just solve for y. So x minus 1 equals to 2y. Divide on both sides. X minus 1 all over 2 is equals to y. But we don't have y in the question, so we can't just use y, right? So what we have to do is we have to replace the y with f inverse. So x minus 1 2 is equals to f inverse of x, and that is it. That's how you find the inverse of a function. But of course it's not going to be as easy as that. We're going to keep getting at difficult questions. So let's try to do that. So the first step was, let's say y is equals to x minus 1 minus 3. The second step was switched out the places. So x is equals to y minus 1 minus 3. Well, next we just have to solve for y. So the first thing we have to do is remember that we have a 3 outside, so we can take 3 outside first, because if we try to take the square root out, we're going to have a lot more troubles. So let's take 3 to the other side first. So now it'll become x plus 3 equals to y plus 1. Sorry, it's y minus 1. Okay, next step is we're going to square both sides. When we square a square root, well, this just goes away. You'll see later why. Okay, so this becomes squared equals to y minus 1. Now we can take the 1 to the other side. That becomes x plus 3 squared, all squared, plus 1 equals to y. Since we don't have y in the equation, or the original equation, we can just write everything again. x1 equals to f inverse of x. And we can write it out again, just so it's a bit bold, clear. Okay, so just some facts here. F inverse of x only exists for 1 to 1 functions. Alright, another thing. So if you were to find so the domain of f of x is equal to the range of f inverse of x, and the range of f of x is equals to the domain of f inverse of x, because they're interchangeable, because this takes it forward, this takes it backwards, this takes it forward, this takes it backwards, so they're, in a way, they are somehow connected, and they have the domain and ranges are also connected. Okay, I think one more thing about the graphs of f of x and f inverse of x, they're usually reflections. So if we have something like this, if f of x is like this, f inverse of x is going to be like this. So there will going to be a reflection line. This is not a good reflection, but in an actual graph you would see you will clearly see any reflection here. Okay, I don't need to remove this. Okay, so yeah, so f of x and f inverse of x will there will be reflections of one another, and that is pretty much along the line. Along the line y equals to x. So this is the line y equals to x, and they're always going to be reflecting in that. Okay, so I think that is everything. That is everything functions. So we've gone over a lot of things. We've gone over what mapping is. The function starts, we went from input to output. We said the function acts as a machine in a way, and we found out how we can use the functions to find values. We learned about the notation, and we learned about the graphs. We learned about domain and range, learned about inverses, the types of functions, and composite functions, all of that. So I hope you understood everything that I've said, and if you have any questions you can ask me, and I will be sure to reply to them.